Now, this is just following the syllabus. And so the syllabus wants you to know how many electrons are in each energy level. And I think they've gone for the mathematical derivation that the physicists have given us. So that's like a 2n squared. So that's what you need to know. So the first energy level or first shell, so 1 squared is 1 times 2 equals 2. And so the second energy level is like 2 squared equals 4 times 2 is 8. And so that's how you get these numbers here. And so there'll be like 4. In the fourth level, it's 16 times 2 is 32. So there's 32 electrons. And so the energy levels also match the number of sublevels. And so it's SPDF. And so each one of these has 2 electrons in it. So there's the 2p has 3 orbitals with 2 electrons in it. So that's the 6. So it's 2 plus 6, and this is 2 plus 6. And there's 5 of them that can hold 2 in each. So that's 10. So that adds up to 18. And there's 7 of these which can hold 2 in each. So each orbital can hold 2 electrons. So that's 14. So add another 14 to that. So that's where you get your 32. And so does it math that adds up? So 2, 8, 18 plus is 32. Yeah. So that's how you get the numbers, and I think that's just the mathematical thing. And so you need to know that. Just learn 2n squared, or learn it this way as well. That's another way to do it. I'll just leave it at that. My preference, I think, still makes a lot more sense. So there it is there. So you can see there's 2 in each here. So each of the 5 can hold 2 electrons. And so that's where you get all the numbers, and they're consecutively added up down here. The first ionization energy, which we've done already, shows that that would be like the first, second, third, and fourth shell, because there's the huge jump here in first ionization energies, because it's very much more difficult to remove an electron when it's a lot closer to the nucleus to another shell. That's why they're those big jumps. And the smaller jumps get harder and harder because it's the same distance away, but it's an increased nuclear charge, which we'll go into in a lot more detail to explain those in periodicity next topic. And so I prefer the experimental evidence, which just goes to 8818, which is probably how you learnt it in junior science. And it also matches the periodic table. The shells sort of match a 2. If you count them across, the boxes is 2, 8, 18. So that's kind of useful to use the periodic table and the experimental evidence, but we need to follow the syllabus and do the mathematical wave equation derivations and use 2n squared to say how many electrons are in each energy level, because that's how they're labelled here. That might not be how it actually works, but that's okay.